So here we have a stack associated with it. Here you'll have the input symbols, that is the symbols on the strings, and these strings will be read one by one and will be processed in the stack. This we have seen in last class. This is just for revising. In stack, we have multiple options in which we have push operation and pop operation. And we have also seen the transition on push operation. I'll just write the transition for revision purpose. Transition symbol from the current state, QI, any input symbol. Let us say I have AB as input symbol. So the first input string what you have is A. Actually, what will be there on top of the stack? Z0 will be there on top of the stack. So I want to push that symbol A onto the stack by changing or not changing the state. So I'll write it as Q for time being. Then I want to push that element onto the stack. Z0. So I've added that element onto the stack. Right? This is the push operation when the top of the stack is Z0. Now let us take one pop operation. See, the input I have is B. Let us consider when I read B, I want to delete A as a situation. What is on top of the stack after the push operation? A is on top of the stack. Now for B, I want to delete A. That is pop. That can be done like this. Transition. I am in the state Q. Right? So what you do from here? The new symbol I have on the tape is B. What is on top of the stack? A is on top of the stack. What I need to do? I want to delete B with A. That is, I want to pop A out of the stack. That means we'll get Q, comma, epsilon. That is your pop operation. Today we'll see some problems relating to this. So we have push operation, pop operation, empty when the stack is empty, and read on top. Okay. So next, we have already seen what is pop operation. It is the process of removing the element from the stack. You can see the topmost element A is removed from the stack. And push operation is adding the element on top of the stack. So A is added on top of the stack here. And no operation is you are not performing, that is you are not adding or you are not deleting anything from the stack. Transition function will have these things mainly: current state, the current symbol, and what is on top of the stack, using which will make a transition. In the input string, the current symbol we have is B. That is, the current input is B. So we are adding B on top of the stack. Right? That is, now once B is added on top of the stack, what will be the next current symbol? A will be the next current symbol. So A is added on top of the stack here, you can see, and its equivalent transition looks like this. That is a push operation. How you are going to write it? See, transition from state Qi, that is the current state, comma, you have A as the current symbol, this A. So A, comma, what is on top of the stack? B was on top of the stack. So B is on top of the stack. So how do you write it? What is the new state that you are going to? Qj, right? You are going to Qj. You are performing push operation, no? So that is AB. You can see here the same transition is written in terms of transition diagram. Transition from QI to QJ, transition from QI to QJ. What is the top input symbol? A is the input symbol. So it is A comma B. B is on top of the stack now. A comma B. Or what is the result of it? AB is the result of it. So that is the meaning of this transition diagram. Okay, so we'll go to the next slide. So we have to see the definition of non-deterministic finite automata. It's similar to your NFA. So what we did in NFA is we had multiple transitions on the same input symbol. The same thing holds good here also. And this we have already seen in the last class, the definition of PDA. It is a 7 tuple where Q is set of states, summation is set of input symbols, and this is the finite set of symbols on the stack. Those symbol set of transition, Q naught is initial state, Z naught, it is the starting symbol on the stack, and F stands for the set of final states, and this is the transition, right? Now, we'll see how the transition function works here. This we have seen just now, how the transition function will work, right? So, two transition functions, we have already seen example for this. First one is for push operation. First one, this is for pop operation, and the second one is for push operation. Here, if you are in state Q1 and B is the current symbol, and if you already have A on top of the stack, then you delete or you pop A from the stack. That is the meaning. Here, the top of the stack is A. Suppose in the input string, if you get B, for 1B, you delete 1A. That is the meaning of it. And there is a change in state here. You can check here. You were in state Q1. Now we have changed the state to Q2. That is a pop operation. And pop operation also can be identified with this symbol. That is epsilon. Right? If you have epsilon, that is a clear indication that you are taking out element from the stack. And a push operation, what is the meaning of this? You are in state Q1. You are in state Q1 and the input symbol is A, and if top of the stack is B, then you have to push that element onto the stack. So you can see AB here, right? Okay. We'll see one problem on this. So the given question is, obtain NPDA to accept the language L of G is equal to A power n B power n, where n is greater than or equal to 1, and the alphabets can be from the set of A and B. That is the meaning. So we'll see an example strings for this. So the example strings can be L is equal to AB, then double A, double B, and triple A, triple B, and so on. Right? So we have to write the set of transitions so that the PDA will accept this kind of strings in which you have equal number of A's and equal number of B's. So now what we do here, we'll take an example of 4A and 4B's, and we'll see how to write its equivalent transitions with respect to PDA. Now what I do here, I'll just take a stack, okay. Let us consider the stack of this kind. Now assume Z0 is already on top of the stack. Okay, Z0 is already there. This string is input string. So we'll see how to write its equivalent transitions. Now, what is the first character we have? A. So its equivalent transition can be written as transition from Q0. What is the first symbol we have? A is the first symbol. What is on top of the stack? Z0 is on top of the stack. So what I tell is remain in the same state, that is Q0, and push that symbol on top of the stack. Now what will happen is this A is pushed onto the stack here. Now, why I pushed A onto the stack is, see, I use a logic here. What is the logic? Push all the elements, all the A onto the stack first. Then for every B, you delete one A from the stack. Then if there are equal number of B's and equal number of A's, then finally if I delete one A from the stack for one B, then finally the stack will be empty. That is what I am performing here. So we'll see that how to do it. Now we are done with first A, reading first A. So what we do now here is we have to start working on the second A, right? Now see here, transition from state, which state I am in? Q naught, right? And what is the new symbol I have here? A is the new symbol. What is on top of the stack? A is already there on top of the stack, right? So what do you need to do here? I have to push that A onto the stack. So it will be Q naught, right? A. See here also, I have not changed the state. I remained in the same state, Q naught, which is a self loop. And what is the reason to remain in same state is, see, after executing this particular statement, whatever A you have on the string will be pushed onto the stack, right? And if we go to the next A, see here, I am in state Q naught. The new current symbol is A. What is on top of the stack? See, the new current symbol is A. What is on top of the stack? A. Push that A on top of the stack. So I can add this A here. Similarly, if I go to next A also, what is on top of new symbol? A. What is on top of the stack? A is on top of the stack. So push that A onto the stack. So I can reuse this transition for multiple number of times for any number of A's. See, in the given question, they are clearly saying there can be n number of A's. So you cannot keep on writing the transition for all the n number of A's. So what I am doing here, I am reusing this particular transition for to push all the A's onto the stack. That is why it is a self loop from Q naught to Q naught. Now using this particular statement or using this transition, we have added all the A's onto the stack. All the A's onto the stack, right? So now it comes to B. All the A's are already on the stack now. How many A's are there? 4 A's. Now what I need to do, for every B, I want to delete one A from the stack. So let us write a pop operation for this particular process. So how do you write it? You have a transition from Q naught. What is the symbol you are reading? B is the symbol you are reading, right? So this symbol you are reading now. What is on top of the stack? A is on top of the stack. So what you do here, for 1B, you have to delete 1A from the stack. That is, you delete this A from the stack. So its transition can be written as, now change the state Q1 from epsilon. Epsilon is indicating your pop being one element there. That means what happens now? 1B is deleted to 1A and A is removed from the stack. Right? Then, how do you write the next statement? Now, what is the next symbol you are reading? One more B. So, transition from state, what is your current state? Q1 is your current state. Q1. And the symbol you are reading is B. What is on top of the stack here? A is on top of the stack. This you can take it as a self loop to delete n number of A's for n number of B's. So you can see here, this is a self loop for epsilon, that is a pop operation. Right? So this deletes 1B with another A from the stack. Then by using the same statement, I can delete 1B to another A from the stack. And again, by using the same statement, I can delete 1B with an A from the stack. So finally, what is the string you have? The string you have is empty, right? So how do you write it? Transition from state Q1, right? I am in the state Q1. What is the input string you have? Epsilon is the input string. What is on top of the stack? Z0 is on top of the stack. So you just go to the final state. Final state can be written as QF or it can be written as Q2 also. So I'll just write it as Q2 here, comma. This will be just Z0. So what is the logic that I am using here? You have, let us consider 3 A's and 3 B's and we'll trace it. See, when you see the first A on top of the symbol Z0, first A on top of the symbol Z0, you just insert that A onto the stack by using the first transition, right? Next, when you see the second A and the top of the stack is A, you insert A onto the stack by using the second transition. In other words, any number of A's you will get, you keep on inserting it by using the second transition. And finally, you will reach a place where you will have a string B, the character B. So when you find B, for every B, you delete one A. Now, we have got B here. So for B, you delete one A using the third statement. And then for every B, you delete one A from the stack by using the fourth statement, which is a self loop. And then finally, if you keep on deleting like this, you will not have anything with you. That is, the string will be empty and the stack will also be empty. So at that point, you have to execute the last statement to halt it in the final state. So this is how you will solve the problem. Now, how do you write its equivalent? See, whatever I have written here is transitions. So how do you write its equivalent transition diagram? That is the next question. So the first you see how many states are there? Q0, Q1 and Q2. So let us write all the states here. I have Q0, I have Q1, and I have Q2. Right? I have three states here. Let me add the transitions also. Which is the final state? Q2 is the final state. So I'll just make it as a final state here. Okay. What is the start state? Q1 is the start state. Okay. Now, I am in state Q1. No, this is Q0, Q1, and this is Q2 final state. Right? Now, Q0 to Q0 is a self loop. First statement. Q0 to Q0 is a self. How do you write it? You write it as A comma Z0 bar the second of AZ0. And second statement is also transition from Q0 to Q0, right? So I can write it here only. So how do you write it? A comma A bar AA. So these two statements are done. Now let us see the next statements. So this one, Q0 on BA is going to Q1. So if you have B comma A, what you are doing here? That's a pop operation. Epsilon. You are changing the state from Q0 to Q1. And in Q1, it's a self loop for B comma A, your epsilon. And from Q1 to Q2, it is epsilon comma Z naught bar Z naught. And Q2 is the final state. Right? So this is how you'll write the set of transitions for the given problem, and you'll write the transition diagram for the given problem. And do you remember in deterministic finite automata, what we did was, first we will write the set of transitions, we will write the transition table, and they will write the transition diagram. Later we will have to show the acceptance and rejectance of the string. Right? So here also, we need to show the acceptance and rejectance of the string by using instantaneous description ID. Okay? So we'll see how that can be written. First, I'll just clear all this. Now you will see the overview of how we solved it. See the solution. The set of strings or the example strings for the given problem is AA, AA, BB, AAA, BB, 4A, 4B, and so on. So the rejecting strings are A comma B, A, B, in which the number of A's is not equal to number of B's. So we have taken a sample string to A to B here. Initially the stack is empty. What we need to do, when we get the first A, we have to push it onto the stack. So we'll push it onto the stack. When you get the second A, again you have to push it onto the stack. When you get the third B, you have to delete one A from the stack. When you get the fourth B, you have to delete the stack on the topmost element onto the stack. So the number of times you push A onto the stack is equal to the number of times you pop the A from the stack. Q naught acts as a start state. QF or Q2 will be the final state. Z naught is the initial symbol on the stack. Set of alphabets we have in this problem is A comma B. And the transition function is, see the first one, when you have the first symbol as A and top of the stack is Z naught, you insert that A onto the stack. That is push operation. Second one, if in the string you are reading A and the top of the stack is also A, you just push that A onto the stack. It is a self loop. You can clearly check here. This works for any number of A's. So now comes the pop operation. When you see the first B in the string, you have to delete the A which is on top of the stack. So that is the pop operation, and you are changing the transition from Q0 to Q1. And second one, the same thing continues but with a self loop. For every B, you will keep on deleting one A from the stack. And finally, you'll be having a string without any input symbols, and the stack will also be empty. So what you do there, you'll write the transition from Q1. The input string is epsilon. I don't have any characters left. And Z0 indicates the top of the stack is Z0. That is, the stack is empty here. Finally, you go to the final state. Right? Now, its equivalent diagram, Q0 is giving you a self loop. The first two transitions change in state from Q0 to Q1, which is the third statement. This one. Then Q1 to Q1 is a self loop. For deleting every A for every B from the stack. And this transition is to just reach the final state. So this is your first problem, that is A power n, B power n. Now we'll see how to show its acceptance and rejectance by using instantaneous description, ID. So the sample string that we are taking is AA. See here, this is in the transition format only. You have a Q0, which is a start state. AA, BB is the string, example string we have taken. And Z0 is the string which is on top of the stack. So forget about these three characters. What is the first character in the string? A. So what we do? Push that A onto the stack. Then you have to push the second A onto the stack. You can see here the A which was on this side, left side, has pushed onto the stack. You can see that here. And similarly, the second A is also pushed onto the stack. Now what you do, for 1B, you will delete 1A, that is pop operation. For 1B, you have deleted 1A. Similarly, for the second B, you will delete one more A. Finally, you have an empty string and empty stack. So you will reach the final state. So the same thing you can do it for 3A, 3Bs or 4A, 4Bs. You will be reaching the final state. Now let us see. Then finally we say the string is empty and the stack is empty, hence it is accepted. Similarly, we can see the string to be rejected. Now what happens here is we have taken the string starting from Q0. The string is AB, AB. It should be clearly rejected. Why? Because the language is A power n, B power n. That is n number of A's followed by n number of B's. This string is not following that. So what we do? First A, we'll push it onto the stack. And when we get B, we'll pop that A from the stack. And you can check here, the state that we are already in is Q1. Right? Now, for next time when you get A, we don't have any transitions from Q1 on A. You can just check it here. We don't have any transitions for Q1 on A. All the transitions are on Q0 on A only. Right? So we say string is not processed completely, but the stack is empty. Hence, AB is rejected. That is how we'll solve the given problem.